Alright, so the first step that I have to do is I have to install one of these bearings onto this lower half of the two-piece broken spindle. By the way, if I haven't already mentioned it, my intention is to put this all back together and rely upon the drawbar pressure to keep the top part of the spindle keyed in and locked into this bottom part of the spindle. If that does not work, then, and only then, well, I revisit the idea of repairing this spindle with a weld. And then I'll have to deal with, of course, a couple of problems. Problem number one is this fine machine surface the bearing's supposed to ride on right here. And problem number two is that it's in very close proximity to the threads that have a lock nut on them right here. So there's the locking nut. You can see the threads, and you can see that that broken area actually goes up past the bottom of this locking nut. Now I haven't disturbed the position of this locking nut, and I don't plan to. So now it's time to talk about a mistake I made on disassembly. Probably there was more than one, but this is the one that has recently come back to haunt me. These are angular contact bearings, single row angular contact bearings. Single row angular contact bearings have to be, they basically will work in pairs, because by design they're designed to be able to take a radial load and an axial load in one direction only. So if you need to have the spindle supported and be able to sustain an axial load and a radial load and axial load in two directions, you have to use two bearings, and you put them in opposite each other. With me so far? Okay. So, I mean, there's actually three ways that you can put these bearings, you can pair these bearings. You can put them both in the same direction. That's called tandem. That's when you want more support, but you only want it in that one direction. And then you have back to back and face to face. And I actually looked up and figured out, found something online explaining why you would want to do one over the other. It doesn't tell you what was done in here, but what I determined is, that, well, I did a couple things. First, I went back and looked at my video, and the reason why I had such a problem, hold on a second, forgot my other paper. Alright, so what I was saying was I made a mistake. The mistake I made was that when I had this all together, I should have cleaned it up really well and taken note which way the top bearing was facing, which way the bottom bearing was facing, so that when I took it all apart, I would have no doubt as to how this went all back together. I didn't do that. The bearings were filthy. They were covered with that disgusting, what looked like a combination of dog poop and earwax mixed together. And so I couldn't really see the bearings well until I had taken them off. Then I cleaned them up. And by the time I had cleaned them up, I had played with them and put them down and picked them up so many times, I wasn't sure which way they were facing. I couldn't be sure. So I went back and I looked at my video really closely and watched really closely and was pretty sure that I could see which side of the bearing was facing which. The angular contact bearings are basically, the outer race is kind of like in an L shape like that, and the inner race is going to be in an L shape like that. And so the ball rides in here, and it kind of, alright, so this is going to be a side cross section of the bearing. Alright, so what you can see here is that there's an angle relationship with where the contact points of the ball is on the inner and outer race. So what ends up happening is when you're looking at an angular contact bearing, there is what they call a thin side and a thick side. And what they're talking about is you're going to look at this outer race and you'll see that that metal is thinner than if I flip it over, that's the thick side. So that's the thin side, that's the thick side. If I put those in and I have them opposite each other, so that one's facing one way and one's facing the other way, that would be either back to back or face to face, but it wouldn't be tandem. But, so I know not to put them both in facing the same way. That would be tandem, that would be bad. Question is, were they back to back or were they face to face? So the first thing I had to do was go online and figure out what they meant by back to back, face to face. And that's when I found out about the thin and the thick thing. Okay? So, you know, this is thicker than this. So then what I did was I went and looked at my video, and I looked at it real carefully. And as I looked at it, I took notes. And I was pretty sure that I could see that this bearing, that I had the top bearing with the thin wall facing up. And then, if that was the case, then I realized then the bottom one should have the thin wall facing down. And I think I caught a glimpse of that. So I was pretty sure that's how it went. And that configuration would correspond with back to back. So then I went online and I found a YouTube video of a company that rebuilds spindles on Bridgeports. Now, the Bridgeport spindle assembly and the Wells Index spindle assembly are eerily similar. Put this broken piece back on here just for a moment. What you have on the Bridgeport is you have one of these bearings on the bottom, you have an inner and an outer spacer, then you have the other bearing on top, back to back with that one. Then this lock nut doesn't exist. Instead, there's a long spacer tube that comes up to here. And at this point, instead of having two bearings stacked on top of each other like the Wells Index has, there's one single bearing up here. And I wasn't sure, but I'm thinking that top single bearing probably is an angular contact. It's probably a regular radial ball bearing. Don't quote me on that, I don't know. But so anyways, so what you got in the Wells Index is you've got two bearings and two bearings, four bearings total. On the Bridgeport you've got three. The other difference is on the Wells Index here we've got this locking nut is actually what's putting the force on these bearings down here. Okay. And then up here you've got this locking nut putting the force on these two bearings over here. And also keeping this whole assembly from being able to be removed from the machine or the quill. So I watched that video, those guys doing that. And what I found out was when I watched them put it together, those are the guys that I learned how to pack these things only 1/4 or 1/3 of the way around. When I watched them put it together, they showed which way was supposed to face which way. So I watched their video and I made notes of their procedure. Oh, right here. Bridgeport video on YouTube. Thick sides face each other. Well, if the thick sides face each other, then that's the thin side facing up on the top bearing, which is exactly what I had on my notes from what it looked like on my video. So I was able to confirm that that's how it's going to go. So the first thing I need to do is I need to install one of these bearings onto here, and I need that bearing to have the thin side facing down. So I look at my two sides of my bearing and I want the thick side facing up. So this bearing needs to go on here like this. Now that's going to be a bear to get this on because of the fact that that's broken. So what I need to do is I need to get this onto there without chipping or damaging this edge. So if I flip this over, and I want the thin side down, if I want the thin side down, if I'm going to do it this way, nope. See, I'm going to follow myself up already. Thin side down like this, then if I'm going to do it this way, I have to have the thin side facing up if I'm going to push it this way. Alright, just use this in the press. It's times like this I wish I owned an arbor press. Alright, so I got this on, and once I pressed this bearing past this point, it basically fell down to this point, because this part right here, this diameter is actually a little bit smaller. So it's a press fit to here, and then it's loose, and then it's a press fit down there. So I just put this sleeve that came out of here on here, and it's actually, I'm actually able to practically push that on by hand. Almost. It's just stopped. Alright, so I don't want to damage that sleeve, because the guys who were rebuilding the Bridgeport, their sleeve design's different on the Bridgeport. You've got an inner and outer sleeve, but you don't have this big, heavy, thick part. This is a lot beefier than on the Bridgeport. And what they had said was you have to measure these two sleeves and make sure they're exactly the same length. And if one's not the same length as the other, you're actually supposed to put one of them on a surface grinder and take a little bit off to even it out. Well, I don't know how one would shrink, other than maybe if like the inner one was spinning when it wasn't supposed to and got ground a little bit. I don't have a surface grinder anyways, so that's not going to be an option for me. So we're just going to have to assume that these are still the same length. But I certainly don't want to bang on this. So we're going to have to find something else, some other kind of sleeve. I actually have an old bearing, I think, that I was using for this. I believe this bearing, yeah, this bearing is, the inner race of this bearing will push on that. Same with that. And then I guess we'll put this. Oh, it's a little higher.
Yeah, let's press it.
Alright, so that takes care of bearing number one. Now the sleeve. Oh, now at this point, before I put that sleeve on, I want to talk about something else, which is these precision matched bearings actually may have markings on them indicating a point that you can line up so that both bearings are lined up with each other perfectly. And I had noticed some markings on these bearings that I was curious about. Mainly on this bearing, there are two small diamonds next to each other. And I believe I saw on the inner race a single diamond. So I'm not positive whether or not this is supposed to be lined up exactly the same. But I don't see the harm in having them lined up if I could find them again. Well, so much for that theory. I actually can't see a mark on that inner race anywhere. I thought I'd seen one on. Oh, well there it is. It's on the other side. Well, heck, a lot of good that's going to do. It's a diamond with a line. Yeah, I can't even see it now. It's a diamond with a line on the inner race of the thin side. Well, the thin side is now on there facing down, and I can't see it. So, what I probably should have did, or should have done, is make note where it was before I fully seated that bearing. Alright, we're just going to have to forego that. Yeah, that's right, you heard me. Now this spacer is just critical to keep the distance between this inner race and the inner race above it exactly right, so that when this is tightened up, it will automatically set the preload on these bearings. Same with this. But that means that it shouldn't make a difference which way it goes. Now, when I took this apart, there was the remnants of a lot of grease in here. So I'm giving serious thought to putting some grease in that. Well, what good that's going to do, I have no idea, because there's going to be nothing in there to cause that grease to... gravity isn't going to make the grease want to just flow into there, right? And yep, I'm going to put a little in there. Now, bearing number 2, thin side up. And that makes sense that that wider side that looked all scuffed up that I thought, and it gave me fits trying to read the bearing number because of the way it was thrust up, the way it was, oops, that's the wrong bearing, the way it was kind of scuffed up. Well, that makes sense now, because obviously the reason for that is because this was precision ground. Thin side up. Oh, I didn't put any grease in that top cup. I went through all the trouble of putting some grease in that other one because I thought it should be there, and then I didn't bother putting it in that one. What am I getting in there now? So I use my squeegee syringe here. Alright, so I got this together, and then that's basically as far as I can go with this. Because what essentially is going to happen is when I put this back in the machine, and the machine's all together, the quill's all together I should say, when I tighten that locking nut that goes in the bottom here with the 2 holes in it, as I tighten that, that's going to push up on this bearing. It's going to push up on this sleeve, which will push up on this bearing, and push it all, it'll push all of this up against the locking nut that I didn't remove right here on the spindle. And that's what's going to set the preload. So I can put this aside for the time being, because the next step is going to be to put this all back together inside the quill with these bearings. Now I recall from before that this whole assembly was designed to come out the bottom of this and be knocked out after you take this locking nut off. Of course, that was supposed to be one piece, so now that means that this has to go in this way. And then, so if I put the bearings on here right now, this isn't going to go in. So what must have to happen is the bearings have to be installed in the top here, and I can actually see the markings that would indicate that these bearings basically were stacked on top of each other. Now I'm back to the problem of, which way do those bearings go in? They have a thin side, thick side also. Well, I've got a couple of clues there. Clue number one is the fact that chances are they're supposed to go in back to back just like the lower pair, which would mean thin side up, thin side down, back to back. Clue number two is if I put them back to back, I can see that these two surfaces, they look like they were either rubbing up against each other or also precision ground. And then of course they say thrust on them, but I don't know which way they're talking about. So if I put them in the way I think they're supposed to go in, the two thrust words, the two sides with thrust on them will face each other, be up against each other. Which coincidentally, I think I saw the thrust word on these bearings and it's the same way. The first one to go in is going to be the bottom one, thin side down. And now I've got to come up with a way to get that in. Because it's pressed into the bore of the quill, I do not want to be putting pressure on that center part of it, the race there. I want it to only push on this outer part. So what I need something that will fit in there. It'll have an OD large enough to push on that outer race, but still be able to fit down that hole.
I love it.
This is the homemade die holder for a tailstock on a lathe that was made by Jim. Yeah, once you know it, that's the perfect size. That was easy. I think. Did that just stop right there? Yep, didn't go down far enough. Maybe this is just a skosh too big to fit down. There's once it gets down to the area where the bearing press is, and I think this OD might be a little bit too big. But I got a solution for that. Thin side up. Sit this one on top of that one, like it's going to be anyways. Looks in. Looks good. Then this goes in from this side. Well guys, this was actually a loose enough press fit that I was able to just grab this splined area and pull it. And actually I think I pulled it right up in where it's supposed to be. Not quite, because the threads aren't exposed yet, but it's getting there. Looks like what I may have done is actually pulled this bearing back up a little bit. That's going to be a bit of a trick. Yeah, I think that's what happened there. Of course I can't put this on with that in there because I'd be better off with a tube. Where's that piece of 2-inch PVC?